Today's topic is differentiation of implicit function. When both x and y occur on one or both sides of an equation, then either x or y is said to be implicit function of the other. For example, this is one example, good example for the implicit function. It is an implicit function. An implicit function can sometimes be changed into the explicit function expressing y in terms of x, for example. However, it's sometimes difficult and unnecessary to do so. Without making y as a subject, we can do the differentiation and find out the dy by dx of that expression is called the implicit function. Let's we do the first question. It is given here 3x square plus 2y square equals to 5x. So differentiate, we are going to differentiate implicity with respect to x, so if we apply the differentiation with respect to x, we needed to write dx of 3x square then plus d by dx of the expression 2y square equals to d by dx of 5x. So with respect to x, if we differentiate 3x square, we know that it gives us 6x. But from the second part, what it is written as a y square, y is a function of x acting here, so we need to differentiate it. First we have to write here 4y, then beside that we needed to write dy by dx. So let me explain this one little bit more. Let's say if we write there dy by dx of 2y square, actually this is, we can write it d by dy of 2y square, and beside that we needed to write dy by dx. So from here, from the first part, we got from here 4y, and dy by dx we needed to keep as a multiplication. So in this way we got this one. And then from the right side, if we differentiate dy by dx of 5x, we got from here 5. Now make dy by dx as a subject equals to, which you can write 5 minus 6x. So dy by dx you can write 5 minus 6x divided by 4y. So this is our answer, having with x and y. Let's move to the second part of this question. Say it is written here 2x square, then hope you would understand clearly the full thing. 4xy written on the right side, then minus 5. If we apply differentiate on the both sides, so we needed to write the full thing, d by dx of, same like before, 2x square, then the next part is plus d by dx of y square, then on the right side, which is d by dx of 4x and y, then the last part minus d by dx of 5. So if we differentiate this, we got from there 4x, and the second part, like the way we did the first one, if it is 2y squared, then we need to write here 2y, then dy by dx, because y is a function of x. But on the right side, 4x and y, it's, we needed to apply here the product rule. 4x one part, say we can write it 4x one part, and another part is y. So we needed to apply here the product rule, d by dx. If I write there, it is definitely u dv by dx, which is dy by dx, then plus y into d by dx of 4x. So from there we would get 4x dy by dx, and then plus 4y because it gives us 4. So we needed to write that part here. I'm going to write it, which is 4x dy by dx plus 4y and minus differentiate of the 5 constant term, it's a 0. So now let to make dy by dx as a subject. Dy by dx, if I take on the left side and take common 2y minus, from here we got 4x, and keep other thing on the right side, which is 4y on the right side already written here, and 4x we can take on the right side, which is minus 4x. So now dy by dx equals to, you can write 4y minus 4x divided by 2y minus 4x. So we can take 2 common and cut out. If we take 4 common from the top, which is y minus x, and from the below you can take 2 common, which is y minus 2 x. So we can cut out 2. Our final answer is 2 y minus x, then y minus 2x. This is our expression of dy by dx. So the third question is C, we prepared for you, which is 1 by x, then plus 2 by y equals to 4. So differentiate with respect to x again. On the both side we are applying the differentiation, dy by dx of the whole thing. Here is also the dy by dx. So from the left side we would get from here minus 1 by x square, we know that, right? And from here we got minus 2 divided by y square according to the rule of differentiation, dy by dx, and on the right side we got 0. So now make this one as a subject, dy by dx, and on the right side it goes positive 1 by x square. Yeah, so now make dy by dx as a subject, which gives us 1 by x square into y square by 2, negative y square by 2. So finally you can write from here, which is we can write it below, minus y square divided by 2x square. So this is our answer of this part. Let's say if by using the implicit differentiation, how we can find the gradient of a tangent. Dy by dx is the expression of the gradient of tangent, we know that, and the value x and y both are given there. So let me differentiate first with respect to x, that expression, then we will go from there 2x plus 2y, then dy by dx, yeah, and right side is 0. So we can make dy by dx as a subject. Dy by dx, if we make as a subject, then we got from there minus 2x by 2y. We can cut out this 2, so minus x by y. Let we put our value x and y. Minus x value is 3, this is the x value, we know this is the x value, and that is our y value. Okay, 3 over 4, this is our answer. So very simple, just we need to find out the dy by dx by using the implicit differentiation. Let's move to the another question. Find the gradient, again the same question of the tangent. Hope you'd understand by seeing my procedure. So let you differentiate with respect to x again, because we know the gradient expression is dy by dx, so we needed to reach our part dy by dx. So if we differentiate with respect to x, we got from there 3x square, then plus 3y square, then we needed to write dy by dx, and equals to 9xy. Actually we have to apply the product rule because two parts are there, 9x and y is there. If we apply the differentiation here, then definitely 9x dy by dx plus y into d by dx of 9x. So we got from there 9x dy by dx, let me write it, and from there we got 9y. So we needed to write the thing 9x dy by dx plus 9y just from 9x. So if we differentiate, we got that term, and if we differentiate the 9, we got 0 from there. Okay, this is our expression. Now we needed to make dy by dx as a subject. So if we make dy by dx as a subject, dy by dx, let me take common from the left side, it is 3y square, and from the right side we got minus 9x, and it is 9y is written on the right side, and 3x square you can take it on the right side. So finally dy by dx equals to, you can write 9y minus 3x squared divided by 3y square minus 9x. We also can take common from the top and make the equation more simpler. So if I take 3 common, then 3y minus x square is remaining on the top, and from the bottom we can take 3 common as is, so y square minus 3x is remaining on the bottom. So cut these 3 and 3. Now the expression is, our expression is 3y minus x square divided by y square minus 3x. Now we are going to put our value x and y together, then we can find out the answer. This is the first value is the x value and second one is the y value. As a coordinate we know that, so 3 into 2 minus x square means 1 square, and the bottom it is 2 square minus 3 into 1, so 6 minus 1 divided by 4 minus 3. So on the top we got 5 and the below it is 1, so our gradient is 5 from this equation, and this is the gradient of the tangent of that expression. This equation known as implicit, and we are doing the implicit differentiation here. We have another question, and it's also similar type question, question number 4, gradient of the tangent. So if you know the gradient of the tangent, easily you can find out the gradient of the normal, gradient of that equation of the tangent, everything you can find out. So next, some of the next tutorial for the implicit I will show in detail that one. So if we differentiate that one here again, which gives us 6x plus 4y, then dy by dx equals to, if we differentiate this, then we got 2x dy by dx, then plus 2y if we differentiate separately, and 23 if we differentiate, we got from here 0, and 2xy like before we needed to apply here the product rule. Just apply the product rule, then we get it dx. Say it the uv 2x dy by dx plus y into d by dx of 2x. So first one is a 2x dy by dx, and next one is 2x if we differentiate we got 2, so it becomes 2y. From there we wrote this part. So now make dy by dx as a subject again. Dy by dx if we take common, then the part is remaining 4y minus 2x, and on the right side it is 2y minus 6x. So without simplification we also can find out the answer. 2y, we got the same answer, 6y 4y minus 2x. We also can take 2 common from there, but no need, we can find out by keeping taking without common. So this is again x value, second one is the y value, put it there, 2 into 2 minus 6 into 3, and the bottom it is 4 into 2 minus 2 into 3, so which is 4 minus 18, this is the 18 divided by 8 minus 6, so 4 minus 18 which is minus 14, and from the bottom we got 2, we can cut out with the 7, so our final answer is minus 7. So this is